This is question number 3, 2018 February March 22 paper. Question number 3 discussion. Calcium and its compounds have a large variety of applications. And this question says calcium reacts readily with most acids. Here, the question gives an acid, dilute nitric acid. Whenever a metal reacts with an acid, hydrogen gas is produced. So in this reaction, when calcium reacts with nitric acid, which is HNO3, you get a salt. The salt is calcium nitrate and hydrogen gas. State symbols are not needed, but we have a balance equation. To balance, I'll write 2 over here. And it's better if I write the physical states also. Calcium is a solid, HNO3 is a liquid. Any nitrate is water soluble, so this is aqueous, and we get hydrogen gas. I said any nitrate is water soluble, but in the next one, when calcium is placed in dilute sulfuric acid, it reacts vigorously at first. If this is a beaker containing nitric acid, HNO3, when you add calcium into this, you can see gas bubble formation. Calcium is a reactive metal, so vigorous gas bubble formation occurs. We had given explanation for these observations. First, we write the explanation for the observation 1. Taking the reactivity of calcium into consideration. Calcium is a group 2 element and it's reactive. We can write calcium is a group 2 reactive metal. It can react with acids to produce hydrogen gas vigorously. But the question says, after some time, a crust of calcium sulfate forms on the calcium metal. A crust of calcium sulfate is formed on the calcium metal. If this is a calcium metal, on the surface, a layer of calcium sulfate is formed. This calcium sulfate is what is insoluble. So if you have nitric acid over here, it cannot come to react with calcium because the contact is prevented by the layer of calcium sulfate present or deposited on the piece of metal. This is water insoluble. Therefore, after a while, the reaction will not happen, reaction stops. And that can be written as this. Calcium sulfate is water insoluble. When this insoluble salt deposits on calcium, nitric acid cannot come in contact. Nitric acid cannot come in contact with the metal. Due to the absence of collisions, reaction stops. Calcium ethanoate is formed when calcium reacts with ethane dioic acid. The compound contains 1 cation and 1 anion. Draw the dot plus diagram of the cation. Cation is calcium 2+. Calcium has 20 electrons. But when calcium makes calcium 2+, it gives out 2 electrons. And calcium has 18 electrons. So this 18 electrons should be shown. First, I'll draw the nucleus. Around the nucleus, you have the first quantum number, and that quantum number can have 2 electrons, followed by the second quantum number. Second quantum number has 8 electrons. Let me draw 8 electrons like this on the second shell, and there are 8 more electrons. They go to the third quantum number. So draw 8 electrons in the third quantum number also. And because it has a 2 plus charge, square bracket, and outside that 2 plus. Draw the displayed formula of the anion. Anion is ethane dioate. Because ethane part is there, it tells that there are 2 carbon atoms. Dioate, there are 2 OH. OH means carboxylate ion. There are 2 carboxylate ions in it. This is the displayed formula of the anion, which is ethane dioate. Calcium chlorate is used as an alternative to sodium chlorate in some household products. Sodium chlorate is used in detergents. So calcium chlorate also can be used for the same purpose. Suggest a use for calcium chlorate. Actually, we don't know that if this information is not given. So you can say in detergent powder. The chlorate ion is formed when cold aqueous sodium hydroxide reacts with chlorine. Write an ionic equation for this reaction. State symbols are not required. Here I want to teach some additional things. We will discuss those things and come back to the question back again. This is about reaction of sodium hydroxide with chlorine gas under different conditions. Chlorine is able to react with sodium hydroxide in 2 different ways according to the condition given by sodium hydroxide. If the sodium hydroxide is cool and dilute, then we have a reaction between chlorine and sodium hydroxide, producing sodium chloride. Plus what is formed. In addition, we have NaClO. This is sodium chlorate 1. Sodium chlorate 1. Similarly, when chlorine reacts with hot concentrated sodium hydroxide, reaction happens producing a slightly different product. The difference comes in sodium chlorate. There is 3 here. NaClO3. And this compound is sodium chlorate 5. Because oxidation number of chlorine in sodium chlorate is 5. I'll get some space over here, otherwise I can't write the stoichiometric values. Balancing the first reaction is very, very simple. You can easily balance the first reaction, which is about the reaction of sodium chlorine with cold sodium hydroxide. At a glance, we can see that on the right-hand side of the equation, there are 2 sodium. But on the left-hand side, there's only 1 chlorine. So probably if I write 2 on the left-hand side in front of sodium hydroxide, we may be able to get a balanced equation. Let's see. I think it's done. Yeah, when you write 2 in front of sodium hydroxide, 2 sodium on the right-hand side, 2 chlorine is there. Okay, oxygen 2. Yeah, this is a balanced equation. It's very simple, but you should know with cold dilute sodium hydroxide, you get this NaClO. That knowledge must be there. But when you go to the second one, with hot concentrated sodium hydroxide, balancing is a little bit different. To balance this equation, we have to consider the oxidation number method. Oxidation number method. We'll see what happens. Here, the chlorine oxidation number is 0. In sodium chloride, oxidation number of chlorine is -1. In sodium chloride 5, oxidation number of chlorine is +5. You can see, so there are 2 chlorine atoms here. 1 chlorine atom goes to -1. It is reduction. Another chlorine atom goes to +5. It is oxidation. When chlorine goes from 0 to -1, it gains 1 electron. But when oxygen goes to +5, it gives 5 electrons. In a redox reaction, the number of electrons given should be equal to number of electrons taken. Now, because number of electrons given is 5, I make number of electrons gain also 5 by multiplying by 5. When you multiply by 5, we have to multiply the sodium chloride also by 5. That's the biggest thing we have to do. Now we can see, because we have 5 sodium here and 1 sodium here, altogether 6, you write 6 in front of sodium hydroxide. Now sodium is balanced. Let's see chlorine. On the right-hand side, we have 5 chlorine here, 1 chlorine here. So I write 3 over here. And then we'll see to balance water or hydrogen. On the left-hand side, we have 6 hydrogen. So I write 3 in front of H2O. This is a balanced chemical equation. So the question is asking not this balanced equation. Question wants you to find out the ionic equation for the reaction between cold aqueous sodium hydroxide with chlorine. That can be done in this manner. This chlorine is aqueous. It's a gas. Chlorine is a gas. Sodium hydroxide is aqueous. Sodium chloride is aqueous. H2O is liquid. Sodium chlorate is aqueous. Before going to the construction of ionic equation, and here to construct the ionic equation, I will delete this last part. And then when a compound is water soluble, aqueous, it means it breaks into cation and anion. This equation I can write again, breaking the aqueous substances into their ions. Now here 2 sodium hydroxide means 2 Na plus 2 OH minus, giving the sodium chloride is also aqueous. So I have write Na plus, aqueous plus, Cl minus. And then water is a liquid, you can't break it down. And next one is sodium chlorate. It is aqueous. We have to break that into sodium plus and ClO minus. This is also aqueous. It's okay. Now we'll see equal terms on either side. On the left-hand side, I have 2 Na plus. On the right-hand side also, I have 2 Na plus. Cancel them out. And that's all. Your equation is going to be Cl2 plus 2 OH minus, giving Cl minus, plus H2O, plus ClO2 minus. This is the balance equation. Balance ionic equation. I can't paste it here. So you can take down this Cl2 plus 2OH minus, giving Cl minus plus H2O plus ClO2. There should be a negative charge. Yes, I have given negative charge. This is a special type of reaction called, this is a disproportionate reaction. It's a disproportionate reaction. What's the disproportionate reaction? A species undergoes both oxidation, this is a disproportionate reaction. If you're asked to explain what disproportionate reaction, you can say it is a reaction. It is a reaction where a species undergoes both oxidation and reduction. Okay? It's a reaction where a single substance undergoes both oxidation and reduction. And in this example, chlorine undergoes disproportionation. I have made a mistake, right? We don't have ClO. Something happened. I don't know. It should be ClO minus. Chlorate 19. Yeah. We'll go to the next part of the question now. Problem number 3. The chlorate ion is unstable and decomposes when heated as shown. See? Deduce the oxidation number of chlorine in each species. Complete the boxes. We can see oxidation number of chlorine here is minus. Here, if anyone has a doubt, okay, this is -1. If I consider oxidation number of chlorine as X, and that's what we have to find out, X, oxygen is, one oxygen is -2. Likewise, there are 3. When you add X2, this is -6. We get the oxidation number -1, the charge -1. So X is equal to +5. So this is +5. In terms of electron transfer, state what happens to the chlorine in the reaction in Roman number 3. 1 chlorine goes from +1 to -1 means it takes 2 electrons. And it goes from 1 electron goes from 1 chlorine goes from +1 to +4, giving away 4 electrons. So I can write 1 Cl minus, no, 2 chlorine, 2 Cl minus ions, 2 Cl minus ions gain 2 electron each and change to Cl, no, Cl plus, 2 Cl plus ions. 2 Cl plus ions gain 2 electrons each and change to Cl minus. And then 1 Cl plus loses 4 electrons. and change this to Cl plus 5. Okay. You have some answers for me. Go to the next one. Calcium lactate is used in some medicines. It forms when lactic acid 2, hydroxypropanoic acid reacts with calcium carbonate. This is a compound. Identify 2 other products of the reaction of lactic acid with calcium carbonate. Okay, one thing you must know is when an acid reacts with the carbonates, I can write the metal carbonate, it's more precise then. When an acid reacts with the metal carbonate, it produces a metal salt, carbon dioxide gas, and water. Here, when lactic acid reacts with calcium carbonate, identify the 2 other products. First one is calcium lactate. I will write all the 3. Calcium lactate is formed. Carbon dioxide is formed. Water is produced. Actually, we had to write the answer without the calcium lactate because it's already given there. The other 2 compounds are carbon dioxide and water. Those are the 2 substances formed. This is the next reaction, which is a reaction scheme actually. It's about organic compounds. See, lactic acid is there as a product. This lactic acid can be formed from 2 substances. The first substance over here is an aldehyde. So there are 2 ways. First one, an aldehyde. Using an aldehyde, we can make the lactic acid. And this is actually an alcohol, a diol. There are 2 OH groups in this compound. And this aldehyde goes to, this compound is hydroxynitrile. We call it hydroxynitrile because it has hydroxyl group and nitrile group also. CN means nitrile group. OH means alcohol group. And the reaction 3 produces over here carboxylic acid. No, this one has 2 functional groups. 1 ketone group is there, 1 carboxylic acid group is there. So this is an oxycarboxylic acid. Oxycarboxylic acid. Not oxy, actually oxo. When we have a ketone group as a substrate group, we call it oxo. So it's an oxocarboxylic acid. This is lactic acid. We'll see how these reaction 1, 2, 3, and 4 can be done. In the first one, reaction 1, aldehyde goes to here, a cyanide group has been added. When you want to add a cyanide group to an aldehyde over ketone, we have to use HCl. HCl should be in aqueous form plus cyanide catalyst. Cyanide catalyst must be there. HCl aqueous and cyanide catalyst. And this cyanide catalyst has produced lactic acid. See what's happening here. There's only one place where a reaction has occurred in reaction 2, and it is cyanide group change into carboxylic acid group. Nitrile group or cyanide group goes to carboxylic acid if you heat with an acid, because cyanide group is unstable. So you can say heat with an acid. Heat with an acid. Now we go to reaction number 3. In reaction number 3, we have 2 alcohol groups. The first one over here is a secondary alcohol. I'll write secondary like this, secondary alcohol. And this is a primary alcohol. Here we have a ketone group. Secondary alcohols go to ketones by oxidation. Primary alcohols go to carboxylic acid by oxidation. So here we have to use acidified, which I write as H+, acidified potassium dichromate, K2, Cr2O7. We have to use heat under reflux. If you use heat under reflux, primary alcohols go to carboxylic acid. And then from this carboxylic acid, we go to lactic acid. What has changed? This CO2H carboxylic acid group has not changed, but then carbon double bond oxygen ketone group has gone to secondary alcohol. A ketone can be changed to secondary alcohol if you use a reducing agent for this. Reducing agent we use here is Al. No, we can use lithium aluminum hydride. Lithium aluminum hydride in dry ether. Or we can use NaBH4 in ethanolic medium. All the necessary conditions and reagents for these 4 reactions have been given on the flow chart itself. Reaction for Y has been reduced to OH. Okay, now see. Let us not use lithium aluminum hydride, because if you use lithium aluminum hydride, carboxylic acid also goes to a primary alcohol. Here only carbon ketone group has gone to secondary alcohol. Therefore, we use NaBH4. Using NaBH4, we can selectively change ketone to secondary alcohol, but then carboxylic acid will not change. If you use aluminum, lithium aluminum hydride, then carboxylic acid also will go to primary alcohol. So we use only NaBH4 for this. And afterwards, you can complete the table given here. It's about reagents and conditions for reaction 1 and 2. If you have taken down these conditions and reagents in the reaction chart itself, you can do the fill in the blanks over here. Name the type of reaction that occurs in reaction 2. Reaction 2. Cyanide group goes to COOH. It is hydrolysis. Reaction 4 uses NaBH4. Okay, question says reaction 4 uses NaBH4. Identify the role of NaBH4 in this reaction. It's a reducing agent. Not only in this reaction, NaBH4 is a reducing agent. Lactic acid has a chiral center. State what is meant by the term chiral center. It is a carbon atom with 4 different groups, 4 different atoms, with 4 different atoms or groups of atoms attached to it. It is not asked in this question, but in certain question papers, we are expected to draw optical isomers also. Now, if I go to lactic acid, this lactic acid is an optically active molecule. We can draw the non-superimposable mirror images. In other words, optical isomers for this lactic acid. When you draw optical isomers for lactic acid, first we have draw the mirror in between. And first start with carbon. Draw 1 carbon on the left-hand side, 1 on the right-hand side. And I will take OH to attach next. Here we have OH up there. In the other one also, we can write OH in the same direction, but oxygen should be on the bottom. And COOH. I will draw COOH in this manner. But in the mirror image, we have to have COOH in the opposite direction. And then we have CH3. CH3 here. CH3 over there. And we have 1 hydrogen. It is drawn at the end of the dotted line, hydrogen here. On the mirror image, dotted line goes to the other side and gets attached to hydrogen. So these are optical isomers of this lactic acid, which is of course not asked in the question, but I told this to you. In case if it comes in your paper, you should know how to do it. So this is a question which is fully about A is organic chemistry, reactions, and yeah, basically it's about reactions. Nothing much, no explanations are asked. I think you understood this concept very well. So this is the end of this question discussion. Let's start the reaction, question number 4, 2018 February March 22 paper. This question number 4 covers some of the basic organic chemistry lessons about reaction mechanisms. And this is basically focused on alkane reactions. Question says, a reaction scheme involving cyclohexane is given. Cyclohexane is a cyclic alkane molecule. See? In reaction 1, we can see 1 chlorine getting added into this. In reaction 2, there's a double bond. One thing you must realize is this. In this cyclohexane, each carbon, a corner in the hexane shows carbon. Each corner is connected to 2 hydrogen atoms like this. It's an alkane molecule. It's cyclic alkane. The product of reaction 1, you can see 1 chlorine added into this. There should be a hydrogen atom also attached to. In all the other carbon atoms, there are 2 hydrogen atoms each. Even though I draw this on the screen, you don't have to try this out in the exam because you should know actually how this structure is. And I do the same thing to this also. Here there's one hydrogen. Here there's one hydrogen. In all the other carbon atoms, there should be 2 hydrogen each. All right, now there's a clearer picture about what's happening. In the reaction 1, you can see 1 hydrogen is getting substituted by chlorine. In the other one, an elimination reaction has happened, an alkene elimination reaction. Reaction 1 involves a free radical substitution reaction. State the essential conditions if it is an alkane undergoing free radical substitution. We have to have chlorine for this and UV radiation. If it's a bromine atom which is substituting here, there should be Br2 and UV. Free radical substitution reaction happens in 3 stages. First one is initiation. This is straightforward theory. First one is initiation. And then we have propagation and termination. This one is also propagation. We'll see what happens. In the initiation, a chlorine molecule breaks into 2 chlorine free radicals. It is for this reaction that the UV radiation is needed. And when this reaction occurs, we get homolytic fission. Homolytic fission. If you are asked to write what is homolytic fission, we have to write it is the breaking. It is the breaking of a covalent bond by sharing electrons equally. It's a breaking of a covalent bond by sharing electrons equally. That means the bond electrons, there are 2 electrons. 1 electron goes to each atom. So it means free radicals. So remember this homolytic fission also. And after the formation of the chlorine free radicals, it reacts with this neutral molecule. Remember, a neutral molecule always changes to a free radical during these propagation reactions, and a free radical changes to a neutral molecule. This neutral molecule is HCl. From where this hydrogen comes? Because there are 12 hydrogen atoms. This structure has 1 hydrogen here, 2 hydrogen here. In all the other places, 2 hydrogen each. I'm not drawing hydrogen, but there should be hydrogen. HCl is produced. In the next step, this free radical, cyclohexane free radical, reacts with a chlorine molecule, making chlorine free radical and this chlorocyclohexane. And afterwards, we go to termination step. In a termination step, 2 free radicals are going to join together. The free radical, in this termination step, this free radical joins with chlorine free radicals, making this compound. This is how the reaction happens. Next one. Name the type of reaction that occurs in reaction 2. Reaction 2 means up here. It's elimination, isn't it? Chlorine goes with the hydrogen in the neighboring carbon, it's elimination. Next one. The product of reaction 2 is cyclohexene. The product of reaction 2 is cyclohexane. Cyclohexane is this. Cyclohexene can be converted into adipic acid, hexane dioic acid. Identify the reagents and conditions for the conversion of cyclohexene to adipic acid. See, this is a cyclic compound. This is a non-cyclic compound. Non-cyclic. In this cyclic compound, there are 6 carbons. In this non-cyclic compound also, there are 6 carbons. How do you get this cyclic compound into non-cyclic compound? We have to break this double bond. To break the double bond, there's only one substance we talk about. It is acidified potassium dichromate, concentrated. What concentrated came in? We can see or acidified, concentrated, or acidified, concentrated potassium permanganate. Potassium, we can write potassium manganate. We write within brackets 7 because oxidation number of manganese is 7 in this. Yeah, what acidified concentrated potassium manganate. Suggest 3 main differences between the infrared spectra of cyclohexene and adipic acid. Okay. What is the adipic acid formula? Adipic acid formula is, I'll draw the structure for adipic acid. It has 2 functional groups of carboxylic acid here, adipic acid. I'll draw it over here. COOH. CH2 is 4 times here. And again, we have COOH. And the cyclohexane is this one. Three main differences between the infrared spectra of cyclohexene and adipic acid. The difference is this. If I talk about cyclohexane, cyclohexane gives a peak in the range for a double bond, but this one doesn't have a double bond. So this is 1. Second example is this, second difference. Here we have OH peak. That OH peak is missing here. It's one thing. And we have carbon double bond oxygen. It is another one, which is not seen in cyclohexane. Suggest 3 main differences between the infrared spectra of cyclohexene and adipic acid. In each case, identify the bond responsible and its characteristic absorption range in wave numbers. There are 3. It's a matter of just looking at the data booklet and getting values. Which is the first one? Cyclohexene has a weak peak in an absorption range 1,500 to 1,680 due to the absorption due to the absorption. Due to absorption by carbon double bond carbon. This is one. Which is the next one? Adipic acid has a strong peak in an absorption range of 1607 to 1740 due to the absorption by C double bond oxygen. My answer. One more difference we can write here. Adipic acid has a very broad, I can write broad, round. Adipic acid has a very strong and very broad round peak in an absorption range, 2,500, 3,000, 3,000 due to the absorption by OH bond in COOH group. You had to learn how to predict the range of a peak, special peaks given by compounds with respect to their structure. The absorption range you have to obtain from the data booklet which is given to you. This is the end of this organic chemistry question. I think it is also not very difficult. Only things we have to read this stuff a little bit.